Alright, so whenever you're trying to do complex circuit problems, you've got to first break down your series and your parallel to make it more simple, because if you try to do it all from the get-go, this is going to be a giant pain in the butt and you're not going to have a whole lot of success. So what you want to do is look for anywhere in the circuit where you could find something to simplify down to make it a little easier. So for example, at this point here, R2 and R3, as I've got them labeled, those two guys are in parallel with each other. So I know that they're essentially going to act as one resistor together. And so if we remember, to figure out our resistance for those guys, it's going to be the inverse thing. So 1 over 5 plus 1 over 7 equals 1 over what's essentially going to be my new resistor, which is going to be 1 over R, and we'll call that 2, 3, just to kind of keep things a little easy. So as I go through and write down my resistors, so I've got R1, R2, R3, but now I also have R2, 3. So when I combine those together, I redraw my circuit. That's still going to be 30 volts. Still going to be 2 ohms and R1. Now, this one is R2, 3. And it has, let's see, what is it's going to be? A resistance of 2.92. So, 2.92 ohms for that. Okay, so if we go ahead and start knocking some stuff down. So I know that the resistance for R1 is 2, R2 is 5, 7 for R3. Then R2, 3, I can write down as 2.92 now. I could also go back, let's see, and then there's a total. So I know the total voltage dropped has to be 30. Now, for the total resistance, since R2, 3 is essentially like this, now I have a nice little series circuit set up. So all I have to do is just simply add those two together to get my total resistance, which will be 4.92. And then from there, I can go ahead and start doing some of the math. So 30 divided by 4.92. So I know that the total current in the circuit, 6.10 amps. Then I also know, Copper, you are in the way. You want to say hi? Oh, you want to say hi? Oh. Here's Copper the physics dog. Say hi. Hello. Alright, go away. Anywho. Blanking. What was I doing? Okay, anyway. So I know that the current through all of my series stuff is going to be the same. So I know the current for R1 is going to be 6.10. And then from there I can calculate out what the voltage will be. So 2 times 6.10, 12.20. Now if the voltage for R1 is 12.2, I know that the voltage dropped here plus the voltage dropped here has to equal 30. So 30 minus 12.2, and I know my voltage is going to be 17.8 across my R2, 3 resistor. And then I also know again that that is 6.10. And then if I do that math just to double check, I wind up with, again, 17.8. So that all checks out. I'm good so far. Now I know that voltage, whenever I hit a parallel junction, remember voltage is not going to split. If I have 30 volts before, I'm going to have 30 volts in each junction. So in this case, since I know over this total area here, between R2 and R3, I know the total voltage drop there is 17.8, meaning that R2 and R3 each have to have 17.8 volts dropped. And then I can go through, calculate out my currents for each of them. Let's see, 3, 5, 6 for R2. 2.54. And then again, if we take our currents and we add them together, we get the total current that was flowing through R23. And since current splits at our junction there, everything works out precisely how we want it to. And so whenever you're doing a complex circuit, and you'll have more practice problems that you can do this with on Canvas if you'd like to have a shot at those before you start going to mastering and falling everywhere, you're welcome to do so. But essentially all these boil down to, and this was a simple one, but all these boil down to is just being able to simplify parts of the circuit. So if you see a couple things in series with each other that is going to bunch things up, take those series things, scrunch them together to make one circuit, to make one resistor. Or if you see a bunch of parallel ones, combine them together, make one resistor. Some problems you're going to have to do this a lot. You're going to have to do a lot of scrunching, and you're going to have multiple different circuits. But every time you scrunch something, or you scrunch multiple things at the same time, make sure you draw a new circuit, because otherwise trying to keep track of stuff is going to be a pain in the butt.